All right. So I've posted the guided notes that we took for this particular lesson. Hopefully that will fill in some of the gaps, but I'm going to just go over a few example problems to just illustrate our point. So today we are talking matrix addition and scalar multiplication. We're going to start talking about addition. The two main things you have to remember is if you can only add matrices or subtract them if they have the same dimensions. So if you look here at 11, notice what are the dimensions of these two matrices? We've got a 2 by 2 matrix over here because there are 2 rows and 2 columns, and a 2, and this is a 3 by 2 matrix because we have 1, 2, 3 rows and 1, 2 columns. So that's a 3 by 2. So we have a dimension mismatch, so we cannot add or subtract these two matrices. So we would just answer this one if not possible. Different dimensions. If we can add the matrices because they have the same dimensions, like in number 10, the addition and subtraction is fairly straightforward. You just kind of have to keep in mind the position in the matrix and keep it the same. So I'm going to go ahead, just kind of draw out a bigger matrix. We're going to just write it out. So consider, here we have 5 and 8 in the upper top corners. So we'll add those two elements to each other. Similarly, we have 7 plus 3. -1 plus 5, I'm going to switch colors so I can keep underlining. 6 plus 1, 3 plus 4, and -9 plus 4. We matched up the elements and just added them together. The only thing here that would change if this were subtraction, for example, if instead of plus, this was a subtract sign right there, is these would just become subtract. And that's the only difference. We're not quite done. We just have to finish adding together all of our points. So that'll be 13. I'm going to go down in columns. 4, 7, 10, 7, -5. Just match up the elements, add them or subtract them as needed. That's kind of the main idea with adding or subtracting matrices. The other kind of thing we talked about today is called scalar multiplication. A scalar is any number that's not part of a matrix. So in this case, at number 12, the scalar is -2. How you multiply a scalar into a matrix, it's very similar to distribution. Make sure that the scalar gets multiplied to every element within the matrix. So let's go ahead and do that really quick. -2 times 5, -2 times 7, -2 times -1, -2 times 6, -2 times 3, and -2 times -9 equals -10, 2, -6, and -14. -12, and 18, positive 18. Anyway, that's kind of the idea of how you do these problems. Feel free to email me with any additional questions or any guidance that you're not understanding. Just generally keep in mind, add the elements that are across from each other, and make sure that when you have a scalar that you multiply it into every single term. All right, let me know if you've got questions.